Good day, students. We are now going to again continue with the chapter 1 because we have not completed very important issues of that chapter. So I will start from where we have left off, that is in my previous video. So here I will start with some of the examples of applications of the identity that we have learned in my previous video. I would request all of you to please study that the previous video which have just been put in our channel just a few days ago. And if you study that video plus study this video, you will get a very good idea about what are the problems which are associated with the number system. So let us start with example 16. So we are going to start with example 16. So example 16, and continuing with chapter 1 of the book, mathematics book, and that's it says simplify the following expression. Now we must know what is the meaning of simplifying. What is the meaning of simplifying? Simplifying means, first of all, separate the rational and irrational parts. Separate means separate the rational and irrational digits or identities, digits or oblique identities. Okay. Now let us, when we do the first one, it says that multiply 5 plus root 7 into 5 plus, I have said root 7 and writing root 5. So be careful when you also do 2 plus root 5. So I have to multiply the way it is being multiplied before. So you see, multiply, first take 2. So that gives you 10 plus 2 root 7. Then you multiply it by root 5. That gives you 5 root 5 plus root 7 into root 5. Okay, so what do you get out of that? You get out of that only further this thing that you can do is there is nothing, all these and this, they are all irrational. So this part of it is all irrational. This is the only rational part of it. So I will write 10 plus 2 root over 7 plus you can write 5 root 5 plus root of 35. So this solves this problem, right? There is nothing else you can do about it. Okay, next one is little bit easy. 5 root 5 into 5 minus root 5. Okay, 5 minus root 5. So I would like to erase this so that you don't get confused with this one. So let me erase this part of it so I can keep on continuing with it. Sometimes this gets confusion. So this would be equal to a square. So this can be a square, a plus b into a minus b. So that gives me a square minus b square. So this would be 5 square minus root 5 square. So that will be equal to 25 minus 5, that is 20. So this is totally rational, right? So there is nothing, no problem about it. Okay, now I don't need this part of this thing, so you have already seen what is to be done, so I can erase and recover this part of the board. So I will use the next one to do the next one is, that was number 2, this is number 3. Number 3 says root 3 plus root 7 and its square. So how do we do it? Again, a square minus b square, a square plus b square formula. We add that would be equal to root 3 square plus root 7 square plus 2 into root 3 into root 7. So that would be equal to 3 plus that will be 7, that will be 2 into root of 21, that is equal to 10 plus 2 into root of 21. Is that correct? This is very, very straightforward. The next one is this one, that we have done it earlier. So that will be number 5, that will be root of 11 minus root of 7. Okay, and now here only this thing has been flipped, that means the minus has come before. So 11 plus root of 7, that will give us, so let me erase this part because there should not be any confusion between digits and saying how did that come and this one. So again that will be 11 root 11 का square minus root 7 का square, that is 11 minus 7, that is equal to 4. So this all came as a rational number. So even we started with irrational number, that came into rational numbers. Okay, now then it is very interesting point, and I will, this is, instead of representing the way it has been represented in the book, I will represent it in a different way. I will now use this example to explain to you how to represent 1 upon root 2 on the real number line. How do you do that? Because it's very difficult. We know how to represent root 2 on number line. There is no problem. But how do you do 1 upon root 2? The best thing to do is always in such cases, first job is to rationalize the denominator. And how do I do it? I can only bring from root 2, either I square it or I multiply and take this one on this thing. I can do it two ways. Multiply both denominator and numerator by root 2. So what do I do? So 1 upon root 2 is equal to 1 into root 2 into root 2 into root 2. Okay, so what does that gives me? That gives me, this one will be root 2 and this one will be 2, which is same as half into root of 2. So in the number line, I will put root 2. I'll find out the position of root 2. So let us say this is about root 2. this is about root 2, this much, then I'll take half of it, So this would be the position of 1 upon root 2. Isn't it interesting? So you can do any 1 upon root 3, you can do the same thing. You can again rationalize the denominator, and you can do the same thing. So this is one of the unique techniques of presenting this one. So rationalizing the denominator, rationalizing denominator is very, very important part of dealing with roots of this kind of with radical or digits with radical signs. Okay, I hope you remember what the digital sign means. Okay, if you don't remember, please refer to my previous video on this subject just before this video. Okay, now it says example 18. Example 18. What does it say? It says rationalize. It says rationalize the denominator of 1 upon 2 plus root 3. Very easy. What do you do? What do you do? You have to do that. So I will take A, this is, I will take it B, I will multiply it by A minus B, so that I get A square minus B square. So, okay. So that will be, then I will do 1 upon 2 plus root 3, multiply these into 2 minus root 3, in order to not change the identity of this number, I have to multiply the top one also 2 minus root. Okay, so utilize this identity. So this one at below becomes 2 square minus 3, okay, because this will be, b square will be minus, and this one on the top will be 2 minus root 3, okay. So this should be what? This should be 2 minus root 3, then this is 4 minus 3, that is 2 minus root 3. Okay, so we can always find out this one. If at the denominator you have 2 plus root 3, at the numerator you will definitely get 2 minus root 3. So in some cases, in MCQs, you don't have to go through these calculations and all that. If you see it is plus here, you put a minus 2 minus root 3. If you see it minus, you put 2 plus root 3. Okay, now let's go through, this is done. Now let us go through another one, which is example 19, which will be example 19. Okay, what would be the example 19? It says, example 19 is again rationalized. So this is 5 by root 3 minus root 5. Okay, is that all right? So what I'll do, without this thing, I'll multiply it root plus 5, and here also I will multiply root 3 by root 5, which is given,